I'm Mark Ingram with Garage Gurus. Today, we're going to show you a technique which can save time in diagnosis of a parasitic drain. Parasitic drain is when devices or modules are drawing too much amperage from the battery with the key off. Generally, anything above 25 milliamps is considered too much. As you read through the manufacturer's diagnostic process, they always tell you to pull fuses in order to isolate circuits. Once you pull a fuse that feeds the module causing the problem, then you can look at the wiring diagram and isolate the problem further. Unfortunately, when you pull all these fuses, number one, there's a lot of fuses on a late model vehicle, and it's going to be time consuming. And the other issue is that when you pull these fuses, sometimes that can wake up a module, and once awake, it can stay awake, causing excess current for as long as 45 minutes to an hour. So if you can avoid pulling fuses unnecessarily, it saves you time in a number of different ways. So what this technique consists of is measuring the voltage drop across the fuse while it's still plugged in. The meter on the right is reading voltage, the one on the left reads amperage. I've set up just a simple circuit on this electrical diagnosis board, and with no current flowing through the circuit, if I measure voltage across the fuse, the meter goes to zero. With it disconnected, you show a small transient voltage that just has to do with the internal circuits of the meter. But connected to a fuse with no current, you show dead zero. Now when I turn on the circuit, now the voltage drop goes to 4.3 millivolts, and the current flow through the circuit is 0.244 amps. I turn it off, everything goes back to zero again. The voltage drop is caused by a very slight resistance in the fuse itself. It's perfectly normal. Now if I switch to a low current circuit, this resistor, if again I measure the voltage drop with no current flow, no voltage drop, but when I energize this, now with only 12 milliamps of current flow, I'm showing a voltage drop of 0.2 millivolts. So that proves to me that this fuse does have current flow. So to summarize, if I go through and measure voltage drop across fuses, any fuse that has no voltage drop, there's no reason to pull it. Any fuse that does show a voltage drop, I should pull as part of my diagnostic process because that could be the source of my draw. Now let's go use this technique on a vehicle. Okay, we're on the car now checking our parasitic drain. I'm using an inductive amp meter, which is the best tool for you to use for this because you don't have to break any connections in order to measure current draw at the battery. You can see from our reading that we're averaging 25 to 28 milliamps, which is just over the specification required of 25. So first thing you want to do as you read through the instructions in the service manual is check for anything being left on or anything plugged in the vehicle. I'll give a quick check. I found that our customer had left a cell phone charger plugged in. By disconnecting that, you can see that our draw has now dropped well under the specification of 25 milliamps. Now we're good. But just for demonstration purposes, let me show you a couple of other effects on this process. One thing I mentioned is that when you pull fuses to try to isolate the problem, sometimes you accidentally wake up other modules. So if I start pulling fuses, I'll just start down here. That one had no effect. I'll try this one. We have no effect there. Oh boy, that one, when I pulled it, the amperage went to 300 milliamps. Now it's jumped up to 1.6 and is holding for right now. So I accidentally woke up some modules by disconnecting that fuse. If you wait a while, sometimes the current will drop down fairly quickly. Sometimes it may take as long as 45 minutes to an hour. So as we watch this, well, there it's back down to 32 milliamps already. So it's almost within spec. If we give it enough time, it should drop on down to be within specification again. But that's one of the issues you run into pulling fuses. If I did have a large draw in the system, there's another technique we can use. Just for demonstration, I've turned on a dome light to cause a high current draw. To isolate which fuse is feeding those dome lights, rather than going through and pulling all of the fuses until the draw drops down, I'm just going to measure voltage drops. So looking at the meter on the right, on this fuse, I'm showing 0 volts, flickering back and forth to 0.1 millivolts. I'll check this next fuse. That one's dead 0. I'll check this one. This one gives me dead 0. 0 over here. Now there I'm showing 0.2 volts, 0.1. And there I have a fairly high draw of 0.8 millivolts. So I've isolated this down to 2 fuses that have a fairly high voltage drop. Those should be the ones that are carrying the majority of the current. So I'll go ahead and pull them. Now you can see the amperage dropped some. Now the amperage dropped back down almost within specification again. But these 2 fuses were identified using voltage drop. I didn't have to pull every fuse on the panel. I can just measure voltage drop to identify the ones that need to be pulled as part of the isolation process. You can see how this can save you a lot of time in diagnosing a parasitic drain. I'm Mark Ingram with Garage Gurus. Thank you.